everybody. Hello, Facebook world. Checking something. All right, there we go. Here we go. Here we go. Hello, hello. It's good to see you all again. Hi, Columbia. We've got North Augusta watching. Irmo. Another Irmo. We've got somebody else watching from New York, I see. So it is so good to see everybody. Thank you for joining us for another Saturday night. We love seeing everybody, and we love joining you every Saturday night. For those of you who do not know, this is our weekly, or currently our weekly telescope live stream. It's more of our astronomy live stream because sometimes the weather is just not great. And I'll let Mr. Matthew talk about that. But the weather's just not great, so we can't live stream anything from the telescope, but we will still talk about an astronomy topic. So I am Miss Laura. I am your education manager here at the South Carolina State Museum in Columbia, South Carolina. I see a lot of familiar faces. Hi, friends. Yes, thank you so much. I was gone last week, but I am feeling great. I just had a little week off, and it was very fun. We had a lot of family time and went to the zoo and everything, so it was very, very fun. So it's good to see everybody. As always, if you have any questions or comments, please chat. Just go ahead and type them in. Just ahead to do it. And so 1, 2, 3, a solid 20-second delay between when you type in something from Facebook and we actually get it, or between when we say something, you type it in, and when we respond, it's about a 20-second delay. So just a heads up on that. We're not ignoring you. You'll usually know that I have received your answer or response or your question because I typically give it a thumbs up or I like it on Facebook. So make sure you're typing in the chat. Let us know what you think. As always, all we ask for is kindness and courteousness in the chat. We ask you to be kind and courteous to everyone in the chat. Please make it a safe and welcoming space for everyone. I'm not exactly the important person here. All right, let me see. Internet connection better, Matthew? Am I doing okay now?
It's okay right now.
Okay, let me know if I need to switch to the MiFi. I'm on my personal Wi-Fi now, but I can switch to my MiFi pack.
Okay.
So for those of you that don't know, the setup I have here at home is a little crazy. I have 2 laptops running and a phone running, so I can read all of the comments coming in, and I can switch screens and upload and unload and share and unshare, and I've got a lot of stuff going on. So if anything's ever going on, just type it in the chat and I will fix it as quickly as I possibly can. If you hear screaming in the background, I'm a parent just like you guys, so or a lot of y'all. So I have my little one getting ready for bed in the back. I've got my 2 pups here, you know, Mr. Matthew. If he's at home, he has a cat running around. So we're all kind of doing our thing and surviving just like you guys are. We can't thank you enough for all of your support. We want to thank Boeing for their continued support as well. They do sponsor this. So we are just grateful for everyone hanging with us through this time and supporting us through this very, very difficult time. We love you and we can't wait to continue doing this kind of stuff with you. I am not the important one. You don't want to hear from me. I'm going to stop yakking and I'm going to pass it over to Mr. Matthew. Hey, Matthew.
Hi, Laura. How are you doing tonight? So good to see you.
Very, very good. A little cold.
Yeah, it's a little cool outside, isn't it? Cool.
Yeah.
And we mentioned the weather tonight isn't so great. So it actually, on my way to the museum this evening, it actually rained a little bit. So when we have bad weather like tonight, we can't see anything in the telescope because the clouds are in the way, but we also don't want to open up our observatory dome because when we open the dome, we are looking out to the outside. The telescope is completely exposed to the outside, and if it decides to rain, it will rain on our telescope. That is a great way to destroy a telescope. And we want our telescope to be right here for you all and right here when the pandemic finally is over, so we don't want to destroy our telescope with rain. So we're going to keep the dome closed tonight, and we're going to show you some cool pictures. And tonight, we're talking about gas in space. And of course, yeah! Of course, I just had to be goofy. Well, before we talk about goofy gas in space, I wanted to just share some updates from the observatory this week. We are now kind of in the thick of our winter distance learning and virtual field trips. This week I taught 5 distance learning programs. 4 were for public charter school, a virtual public charter school with kids around the state, and 1 was for Richland 2 elementary school. And I also had a really great conversation with a high school student who was working on a school project and needed to talk to an astronomer. So we're doing lots of cool virtual teaching here in the observatory through this time. We're going to have a lot more of this distance learning coming up. In a couple of weeks, I think it's the entire Irmo Middle School Science 8th grade. It's going to be 12 programs throughout that week. So that's going to be a little crazy, but that's good.
That's going to be awesome.
That's why we're here.
Yeah. Well, if there are any teachers out there watching or anything, we not only we do the observatory stuff, but we also have, you know, different versions of this in STEAM. So if you have any questions or anything, just email me or Mr. Matthew, and we will get it to each other and find the right thing for you, because we have a bunch of different subjects too. But the observatory is definitely the most popular.
You are invited to hunt us down, teachers. So unfortunately tonight, again, it's cloudy, but we're going to show you some really cool pictures of gas in space, and actually what we call nebulae, these giant gas clouds in space, and these are often places where stars are forming. So I just wanted to get us started here. Miss Liz actually has some really amazing video and simulations and pictures. I'm just going to get us started here a little bit by showing you, let's see if I can get my screen share working right. I'm going to just show you some overall pictures of this whole topic of gas and nebulae in space. So let me get my screen share going. This is a really cool website that I recommend checking out. It's called Astronomy Picture of the Day, and it's apod.nasa.gov. Or if you Google Astronomy Picture of the Day, you will find it. But this is a really cool picture. It's today's astronomy picture of the day, and this is a picture of the Milky Way. So the plane of our galaxy being taken off from an airplane on its way to Lima, Peru. So if the airplane's on its way to Peru, we're actually looking at the southern hemisphere. So this is the Southern Cross right here, which is my favorite constellation. But you'll see all through this sort of hazy starry area are these dark areas. This is dust in space and cold gas in our galaxy. And then you'll also see these areas where the gas is a lot brighter. There's an area there and there. And when we see these gas clouds, these are places where stars are forming. And then I'm just going to scroll down because this picture has really got some cool stuff down towards the bottom. Just for fun, you can see here's the horizon from the plane. You can see the clouds below the airplane. The airplane's at like 38,000 feet. And then these two hazy spots right here are actually not in our galaxy. These are the large Magellanic Cloud and small Magellanic Cloud. These are galaxies that are satellite galaxies of the Milky Way. And I think we might have a question.
What is a Magellanic Cloud?
What is a Magellanic Cloud? So they are named the large and small Magellanic Clouds because Magellan was the first to actually, I think, write them down on his voyage around the world. But they're actually small galaxies. They're satellite galaxies of the Milky Way. So that's what they are. And I think they're so pretty. And
they are, they're beautiful.
You can't really see it, but the Large Magellanic Cloud has another one of these star-forming gas clouds in it called the Torrential Nebula.
Ooh.
Maybe we'll find you a picture maybe in the next program of the Torrential Nebula. And now just for fun, I'm going to show you yesterday's astronomy picture of the day because on the subject of gas and gas clouds in space, this is something called the North American Nebula. And the North American Nebula is another one of these giant gas clouds. And it's in the constellation Cygnus, so we see it more in our summer sky. And just reminding myself of where this picture was taken, looking at the description, this was actually taken over some mountains in British Columbia up in Canada. So it's this really beautiful nightscape. So
wow, that's gorgeous.
Isn't it gorgeous? Yeah, it's so.
What makes the different colors? Why is this one so pink or red?
So usually when we see a nebula that's got a lot of red in it, that's an indication that there's a lot of hydrogen gas in the nebula. And hydrogen is by far the most common gas in the universe. Space is full of hydrogen.
Oh, okay. Okay. All right.
So I just gonna switch pictures here real quick. And so tonight we're talking about the Orion Nebula. And this is actually a picture of the Orion Nebula, this gas cloud where stars are forming, from our telescope. We would have actually showed you a live picture from our telescope if tonight hadn't been cloudy. But never fear, I have this really amazing picture from our telescope that we took in the past that I can show you. So you can see all of this gas here. And then inside the nebula are these stars. You can see these stars right here. And these stars are actually stars that formed in the nebula. They're super hot and bright, and they're actually making the nebula glow. So really beautiful. Miss Liz, did you want me to show where the Orion Nebula is in the sky, or did you want to do that?
It's up to you if you want to show
Hi,
where it is.
Yeah.
Hello. Hey, I just didn't want to jump in too early.
I was just I can pop up Stellarium really quick and we can show you where the Orion Nebula is. I think, let me go ahead and do that.
Yeah,
You
that'd
know
be a good idea.
That was totally me being a bad host. I should have introduced everybody. I'm here with Mr. Matthew and Miss Liz tonight. I'm sorry.
So do you know what I tend to do when I teach distance learning? Is I'll start talking and say, hi, everyone. This is our observatory here at the South Carolina State Museum. Look at our cool telescope. Oops, I should introduce myself. I'm Matt, observatory manager.
I do that too.
I do that all the time. It's like, who's this freak speaking to me?
Uh-oh.
Laura's internet is not happy.
Laura's freezing a little bit.
Laura's freezing. Does that mean it's
Well,
cold in Laura's house or something?
It is very cold.
Woo,
Am I back?
freezing.
you,
All right.
yeah, you're back.
You're back, Laura.
Okay.
All right, let's see if I can get this thing to set up right. Why is my keyboard today? It's just, I've been having all kinds of tech issues in the observatory, and today is no exception. Let's see
We
here.
have a question.
Awesome
and
question.
The question is from Teddy, and Teddy would like to know, what is a constellation? And I would add to Teddy's question for our South Carolina students, they have to know a standard. What's the difference between a constellation and an asterism?
All right. Well, that's a great question. So a constellation is basically a grouping of stars, and typically they form a pattern. So tonight we're really focusing on Orion the Hunter. And then an asterism is any group of stars that's not really a constellation. There's some common asterisms, and one of them is over here in the northern sky. So I'm actually going to flip the sky around. I'm in the mood to make you all dizzy tonight. So woo! Just kidding. I'm going to flip the sky around to the north. I'm also going to turn on the constellation labels and lines so you can see where we are a little better. If Stellarium will listen to me. What is Stellarium doing?
Yes, while Matthew's doing that, I have one.
It's like I'm clicking on
Well, while
Constellation.
Matthew's doing that. Uh-oh.
What is
Hi,
going
Liz.
on?
Liz, are you having trouble
Oh, okay.
too?
Yeah, I'm getting an internet connection unstable, so
right,
I
so-
think if I disappear, that's why.
So Liz and I are
But-
neighbors, everybody. So for I guess I'm guessing no, Liz and I are neighbors. We're literally like, we could throw a rock and hit each other. And so there might be something going on in our neighborhood.
Well, so there's something going on here at the observatory too, because I'm clicking on the buttons to turn on the constellation lines and labels in Stellarium. And guess what? The lines and labels are not coming up. So
Oh, weird.
I have no idea what's going on. I think the dome gnomes must have gotten.
Well, while you're figuring that out, I do have something to add about the constellations versus asterisms, because they are both groupings of stars, but for the official constellations, there is an official set of 88 specific groupings or star patterns that was decided upon by the International Astronomical Union back in the 20s. So anything not in that official set is considered to be basically an asterism, which is kind of like just a popular pattern of stars. although cultures all over the world throughout human history have created their own constellation sets, so those exist as well. But the modern set that we talk about today, like Orion the Hunter and his 2 hunting dogs, and some things that Matthew's trying to show us, those are part of that official set of 88, which does have a lot of Greek myth characters.
And a simple way to think of it, I think,
here they are.
one of the simpler ways to think about it, I think, is constellations have stories and asterisms typically don't.
Right.
Not all constellations have stories, though, I don't think, because I think some of the southern hemisphere ones.
Yeah,
like
for our South Carolina
Telescopium.
academic standard students, that's how they're taught it. We look at the northern ones. So for those academically northern ones, for our South Carolina students, the way they're going to define it for you is that they have stories and asterisms don't. But Liz, I think you're right. There are some that are just kind of out there.
Those southern hemisphere constellations, some of those are weird.
The southern hemisphere ones have a lot of just instruments. So you'll have microscope, a telescope.
I forgot. Yeah, there is a microscope and stuff. Matthew, that just sounded so snooty of you. Those southern ones, those southern constellations.
Dana. Anyhow, well, I actually exited Stellarium and brought it back up, and now it's working. This seems to be a theme of this week. So earlier this week, I was doing a virtual field trip run through with the teacher, just testing everything out to make sure the internet connection was working. And well, I could see the teacher, but I could not get my camera or mic to work. And the teacher was like, what's going on? I can't see you, I can't hear you. And I couldn't tell her what was going on because I couldn't communicate. So I had to actually write her an email saying, hold on, troubleshooting. And then I actually turned off my computer and turned it back on. And guess what? The camera and microphone were fine.
Yep.
Yeah, so
Yep.
it's tech. Anyhow, so one asterism that I think that it's actually really probably one of the best known ones is the Big Dipper. And we have a little issue right now, and the Big Dipper is not all the way up. So what I need to do is go a little further into the night. And now you can see the Big Dipper right here. So here's the bowl, here's the handle. And the Big Dipper is actually part of Ursa Major, or the Big Bear. I'll turn the constellation artwork on, and you can see our bear here looks quite like a bear, the Big Bear does. And then we have Ursa Minor, the Little Dipper, the Little Bear. Why did I say deer? There's actually some inside jokes we have here about deer.
I wonder.
But I think this bear right here looks like a dog.
Yeah, that tail is kind of long, yes.
Yeah, that nose looks like a dog nose. And those look like dog ears, so. All right, well, let's flip back around here and have another look at Orion, since that's what we're chatting about tonight. So here's Orion right here. It's this big constellation this time of year that's high up in the south with these really bright stars. One way to find it is to look for these bright stars that form like a rectangular box. And then in the middle of that are these 3 stars in a row that form the belt. Now the Orion Nebula is up. I think we might have a question. Let's
Well, you can feel free to finish this section, but this kind of goes along with what you're showing right now. Teddy would like to know what stars are made of when you're done.
Okay. Well, we'll actually be talking a bunch about that throughout the program. So the Orion Nebula is actually in the sword of Orion, which are these 3 stars right here. But the thing is that the middle star actually isn't a star. So I'm going to zoom in here and watch that middle star and see what it actually is. See, it's not a star. Giant cloud of gas in space. That's the Orion Nebula where stars are forming. So stars are mostly made of hydrogen gas with some helium and some other types of elements just thrown in. But stars are largely, they're big spheres of hydrogen gas. So that's what I wanted to show you with where to find the Orion Nebula in the sky. So I'm going to make Stellarium go bye-bye here. And I think Miss Liz has lots of really cool pictures, so I'm going to hand it over to her.
All right. Well, thanks for showing folks where it was in the sky. I think it's appropriate a little bit that we're talking about space clouds when it's cloudy out. So I'm going to throw up some pictures here. So give me a second to pull this up. Okay. All right. Okay.
And then Miss Liz, while you're getting that set up, we had another question come in. So one question is, what are stars made of, which is a great segue into this. And then the other is actually about, oh, I lost it, the pillars of creation. Is it its own nebula or is it inside of one?
Yeah, so the pillars of creation are part of, I believe, the Eagle Nebula. Did I get that right?
Yeah, that sounds right. It's it's part of another nebula.
The nebula is actually very similar type of nebula to the Orion Nebula in that it's another one of these nebulae where stars are forming.
Yeah, well, that is a good question. Well, this picture here, can you see this okay, Miss Laura, Miss and Mountie? All right.
Beautiful.
This is a picture I used in my virtual skies tour a few weeks ago. It wasn't this past week, a few weeks ago. And I wanted to show this one because it's a little hard to see, but if you look towards Orion, and I know you can see lots of other stars in here, but there is a lot going on in what I will call the neighborhood of the Orion constellation. So if your eyes were really sensitive and could pick up all of the faint light coming from the constellation of Orion, you'd actually be able to see a lot more. There are a lot of space clouds or nebulae in this direction, and they're all kind of grouped together in something called the Orion molecular complex. So just a big complex full of different types of clouds. Can you see the Orion Nebula in this picture?
I think I can, yeah.
And I don't know if you can you see my cursor at all? Or
I can,
no?
yes.
Okay, you can?
Wait, hold on. Do it again. No.
I'm moving it around. No,
On
okay.
Facebook.
Okay. If you can't see it, I'll just try to describe where I'm looking at. So the Orion has 2 bright stars in his shoulders, 2 in his legs or feet, and then 3 stars in a row that form his belt. Below that belt are the sword stars. And one of those stars, as Matthew pointed out, is a bit fuzzy because it's not a star at all, but a star forming region. And hopefully you see this kind of, there's a ring of like a big arc, kind of like the letter C of reddish gas there. It kind of makes Orion look like he has a belly. And then there's kind of like a poofy bit of gas up where his head would be. So there's a lot of gas in this direction. That big thing that looks like the letter C is called Barnard's Loop. And the big clump of the fuzzy patch that is where his head would be is I think that's, I can't remember the name of that, but it's something like the Beta or Lambda Orionis loop or something like that. It's got a not too memorable name to it. But I thought we would take a tour of some of the different types of clouds that are towards Orion. The Orion Nebula is nice because you can see it with your own eyes or with binoculars or with a small telescope, depending on how good your viewing conditions are. The other stuff you can't really see with just your eyes. This is a timed exposure, or actually lots of different images that were kind of added together so that you can see the very, very faint light coming from this direction. This is the Orion Nebula taken with Hubble, and I think it's in different wavelengths. So it's a close-up view of the Orion Nebula. There's actually 2 nebulae here. So the Orion Nebula is also nicknamed M42. It's a catalog number. M stands for Messier, after a French dude named Charles Messier, who kind of cataloged all of the faint fuzzies up in the sky. The top part, kind of in the upper left corner, is actually M43. So it's kind of its own little nebula there, but they're kind of connected.
So I'm going to jump in. Do we have a question?
We do. We actually have a very general, simple question. Teddy is like super into the live streams. What up, Teddy? We're so excited that you're loving this. Teddy would like to also know, what is a nebula? And I think our friend Teddy is a little on the younger side.
Okay, so a nebula is basically a giant cloud in space, and it's made of gas and dust. So these clouds are much, much bigger than clouds in the sky, because they are so big that you have entire stars forming in these clouds, and you have entire solar systems forming inside of these clouds. So they're much, much bigger. The Orion Nebula is about, I've seen different estimates, 20, 30 light years across. That means if you traveled the fastest you're allowed to go in the universe, the speed of light, it would take you decades to go from one end of that cloud to the other. So that is how incredibly huge these clouds are. And there's lots of them in space. So basically the short answer is space cloud, big giant space cloud. And there's different types of them. So today we're primarily focusing on the star forming ones, the ones like the Orion Nebula, where there's just so much stuff there that new stars are forming out of all of that material. Even right now. So that's why it's called a stellar nursery or a star forming region.
Where little bitty
where
baby stars are made.
baby stars are forming. And so in terms of stars though, when they're babies, they are, you know, a few million years old. So these stars are, you know, 1 million, 2 million years old. So those are baby stars. But I don't know, when I look at this picture, I instantly see a superhero. I don't know if anybody sees that, but
Yes.
M43, that cloud at the top looks like a head with maybe like a mohawk or a crest. And then it looks like to me like a person with a cape. His cape
I can see that.
wide, and he's just soaring through space. So I always think of Orion as a superhero, not the constellation, but the Orion Nebula, because that's what he reminds me of. And one thing I do have to point out about this image, because whenever people see the Orion Nebula in a picture like this or through a small telescope, a lot of times I'll get people who exclaim, "Oh my gosh, I see Orion's belt." And I can totally see why. Matthew, have you gotten that?
All the time.
All the time.
Yeah, it makes sense. Yeah.
And I don't know if anybody else sees 3 stars in a row towards the center of this picture.
Yeah, I could definitely see where you would get that. Yeah.
Yeah, and so it's those are 3 stars in a row. They just happen to kind of look like the belt stars. But just remember that we are looking in one of the sword stars, so to speak, is an object that's in the sword of the constellation Orion. So the belt stars are far to the north. So you can't get all of the belt stars in the eyepiece of a telescope because they're part of a constellation. They're more spread out in space. But it is kind of neat that, I mean, it kind of looks like,
Yeah.
that. And it's in the Orion Nebula, so kind of goes together.
So what Liz was
this is one of the closest star. Oh, sorry, Matthew, go ahead.
Oh, so what Liz was saying about the stars in the belt being more spread out than these 3 stars we see here in the nebula. One great way to think of looking at the sky with a telescope is you're basically looking at the sky through a soda straw. So think about taking like a straw that you might use to drink a Coke or Slurpee or whatever, and you're looking at the sky with this little tiny straw. That's kind of like what looking through the sky in a telescope is like. You're just seeing a very tiny part of the sky. So the belt stars actually would not fit in one telescope field.
Yeah, that's a really good point. We are zoomed in on one teensy tiny little piece of the sky. So yeah, just in one object in the sword. Oh, and so this is, besides being part of the constellation Orion, which is a pretty famous constellation, this is a pretty famous star forming nebula because it's one of the closest ones to us. I think it's the closest one to us. It's just under 1,500 light years. So again, if you were traveling the fastest you're allowed to go in the universe, the speed of light, it would take you just under 1,500 years to get there. But that is close in terms of astronomical terms. So it's an opportunity for us to study the places where stars are formed, because it is reasonably close. And so it's one of the brightest star forming regions to us. And it's in one of the constellations that we really, really like. Okay,
Well, and
so
like
at the
it's I think it's the Graves family. Yeah, Mr. Matthew. They're always on. We love this family. Like you said, you know, it's what's neat about the Orion Nebula is that you can see it with a pair of binoculars. So you can, you know, you don't have to have a really powerful telescope for some of this stuff, right?
Right, exactly. A small telescope or binoculars will show you that gas cloud.
Mhm. Well, so the Orion Nebula has thousands of stars in it. However, if we zoom in towards the very center, so there are those 3 stars in a row that kind of look like a belt, but actually what's doing most of the clouds, so doing most of the work making it glow, is a star cluster at the very, very, very center of the Orion Nebula. And it's called this Trapezium star cluster. So we are now zoomed in even more at the very heart of that giant space cloud I just showed you a picture of. And so it's called a trapezium because the 4 brightest stars in this area kind of looks like a trapezoid. So hopefully you see that. I can make that out if I look at the 4 brightest stars here. And so these stars are basically causing the gas to glow. And actually the brightest of these, the most massive of these, is the one that's kind of at the lower part of the screen there, or lower half of the screen, I should say. And what it's doing is ionizing the gas. So what that means is the radiation coming off of these young stars, these hot young stars, the radiation is so intense, it's so strong and intense that as Matthew said earlier, these clouds are mostly hydrogen. It's basically ripping the electrons off of the hydrogen. So for those of you who are unfamiliar with how hydrogen's structured, is 1 proton, 1 electron. And what this intense radiation does is it separates the electrons from the protons, and that's called ionization. And then eventually the electrons, though, get back together with the protons. They're opposite charges, one's positive, one's negative. They do kind of want to be back together. So they eventually get back together, and that process releases light. And that's why the cloud seems to glow. So it's not glowing really just because it's hot or something that's a little more familiar like that. It's actually what's happening is you're seeing lots of what I like to call happy reunions between electrons and protons. And so lots of happy reunions gives you lots of that pinkish glow that seems to come from these clouds. So most of the intense light that's doing most of that is coming from these stars that's just nestled at the very, very heart of that nebula. All right, do we have any questions before I go on to the next bit?
Not right now. We have
Okay.
Miss Sam saying hi. Miss Ava is on.
Hi.
Cassie and Stephen are saying hi. We haven't seen them in a long time, so it's just a lot of people just saying hi, but no questions right now.
Okay. All right. Well, hi everybody. Okay. This next bit, I just have a placeholder here where what we're going to do is do the simulated flight through the Orion Nebula. So this is a scientifically constructed simulation of what it might be like to actually go to the Orion Nebula and fly through it. So what I'm going to have to do here is stop this screen share because I'm going to jump out and I'm going to share something else with you.
Liz, I do think something is going on because we just lost Matthew and he's at the museum with like the good.
I was about to say,
I don't know where he's at.
I jumped out of screen share and then I thought I accidentally booted him or something. So I'm like, there's one less person. Like,
could be a
well,
black
hopefully
hole.
he gets back.
We have no idea. But Matthew,
No.
we miss you. Oh, cool.
Okay.
Liz says her dogs are named Orion for the Orion Nebula.
Oh, that is awesome.
I've got a dog
Okay.
whose middle name is Sirius because he has one blue eye and one brown eye.
Aw, that is super cool. Okay.
Matthew!
Is Matthew back?
No. You keep doing your thing. I'll make sure he's okay.
Okay, well, hopefully, you can see the video here instead.
Yes,
Okay.
that looks great.
There might be a gray bar at the bottom. If there is, I will try to make it go away. But
No,
if
it's not showing up this time.
Oh, sweet. Okay.
Yeah, I know.
But so this is hopefully, so this is a wide view. And so hopefully you see Orion in there. He should be about the center of your screen. Because again, I don't know if you can see my cursor. So he's about the center of the screen. Remember that picture I showed earlier where it's got that arc of red gas called Barnard's Loop, that big kind of cloud poof.
Miss Liz, what might help them, Miss Ava actually said something a few minutes ago. She said it actually looks a little bit like BB-8. So maybe
Yeah.
you can't see your cursor on Facebook. So yeah, maybe that's a good way to point it out.
Okay, so for those of you familiar with Star Wars, it kind of looks like BB-8 tipped over on his side, just red. So there's the constellation of Orion with all of the gas structures that kind of span that constellation. And I'm going to start this video. It has no sound, so I'm just going to talk over it here. But we are going to zoom in and get closer and closer to Orion, and we're actually going to go to the Orion Nebula. So we're zooming in, and this is actually a simulation that we can play on the planetarium dome, which looks really, really cool. So there's that picture of Orion, and so that's actually off to the left. That is what Orion looks like in visible light, and on the right, infrared light. So I'm going to pause it right there for a second. On the left is the view of the Orion Nebula invisible. So that just means the colors of light that you and I can see. So we can see the colors of the rainbow from red, orange, yellow, green, blue, purple. Those are all the colors we're familiar with. But there are more colors than just what we can see. There are colors that are redder than red, for example, and colors that are more purple than purple. And our eyes just aren't able to detect that. But we can build detectors that are able to see in those wavelengths of light. So where it says infrared view and it says Spitzer, that is a picture of the same nebula, the Orion Nebula, that's taken in infrared light, which are colors of red that are redder than red, so beyond red, taken with the Spitzer Space Telescope, which has now been retired. It's no longer working, but it took this picture of the Orion Nebula. And in this simulation, they're going to combine the light from both the visible, the colors that we can see, and the infrared light. So here we go. We're going to keep going. So this is visible and infrared, and I think they overlaid the two there. And we are going to start flying through it. So when you look in infrared light, you can see a lot more. So this is what it would be like if we were in a spaceship. We could go 1,500 light years to the Orion Nebula and then just kind of descend through it. So it's almost like these mountain ranges and cliffs and just really cool structures just made of gas. And you can see all of those bright young stars that are there. And we're kind of going towards the heart of it where the Trapezium star cluster was that I showed you earlier. So basically, parts of the cloud are collapsing. They get dense, they collapse, and then fusion starts and you get a star. And so that's happened in many little spots in this nebula, and we're about to fly by. I'm going to pause this video as soon as we get to about right there. Okay, do you see that little black disc?
Yes.
Near the center?
Yes.
So that is an example of something called a proplyd. So that is short for protoplanetary disk. It's a baby solar system, basically. So we have stars forming. What orbits around stars? Planets. And so basically, when some of these stars form, if there's some leftover gas and dust that swirls around it. Sometimes planets can form out of that. So there could be planets forming in that little dark disk we see right now. So there's lots of those little proplyds in there. We're going to keep kind of soaring over the, I shouldn't say landscape, cloudscape, if you will. And so it's just a really neat way to kind of take a tour of the Orion Nebula and to get you thinking that, you know, sometimes when we look at these flat images, these are really 3D structures. These clouds aren't flat. They have, you know, width and depth and height to them. And this gives you an idea of what it would be like to go through one of these clouds. And I think we're coming up to the end of it there. So yeah.
That is
All
so
right.
pretty.
That is stunning.
And so if you want to see this, this came straight off of a NASA site called the SVS Science Visualization Studio, I believe, and they have lots of really neat visualizations. And so this is something that I love to do in the planetarium, because then it's on the big dome and you get even more of a sense that you are actually there. So, okay.
Very cool. That was beautiful. That was gorgeous.
Let me go back to, do you have any questions here before I go back to where I was before?
Not yet. Just a few people talking about how pretty it was, but no questions yet. If you guys have any questions, let us know. Even if it's not specifically about nebula, that's okay. Oh,
Okay.
I have a question.
What is
the plural of nebula?
Nebulae.
Nebulae, it's with an A, E at the end, but sometimes people say nebulas and it's not terrible. It's okay. I think technically it's nebulae or nebulae.
Gotcha. Okay.
Okay, well, hopefully you can see now this other picture I have here. This is M43, so kind of the gas cloud that was attached to the Orion Nebula, which I thought looked like a head, like the superhero's head. So this is a close-up view of that, also invisible and infrared, so you get more information. We look at infrared a lot because actually infrared light, that light that's redder than red, does a really good job of traveling through dust. So it's hard to see when there's a lot of dust in the way. The colors of light that you and I see, the red, orange, yellow, green, blue, purple, especially towards the blue end of the bluer colors, they really get blocked by the dust a lot. But if you could see redder than red, those colors just make it through so you can see more. So a lot of times when we look at these gas clouds, we look in both visible, our familiar colors, and infrared as well. And then you can combine those images into one. And so this is kind of a zoom in, which I think is really neat. So that in the center there, that bright star just kind of looks like Orion's eye to me. If Orion was a superhero, that would be his eye. And oh yes, Laura.
Oh, if it's yeah, you don't. I'm sorry, I didn't mean to interrupt you, but we did have a question come in that you can answer anytime. But it is how many? Let me make sure I get it right. Yeah, how many stars do we think are in the Orion Nebula?
One of the articles I read had it at, we know of a few, I think 2,000 or 3,000 so far. And I don't know, so it's probably in the thousands.
Interesting. I thought it would have been higher.
There's probably more in there. I don't know how many there are in there total, but I just know that
not that I'm not impressed. I'm definitely impressed by, you know.
It gives you an idea of how much stuff is there.
Yeah.
How much gas is there, because not all the gas gets turned into stars, just some of it. So I mean, there's enough gas there to form a lot more if it all turned into stars. So yeah. Okay, so this is just a
Ooh, that's so pretty.
I know.
That
was gonna say. So this is getting away from the Orion Nebula, but still in the constellation of Orion. So as I said earlier, we're not looking at just the Orion Nebula, but just kind of nebulas or space clouds in the Orion neighborhood. So in that Orion molecular complex that I mentioned earlier, there are other gas structures, there are other gas clouds, and then there's this one called the Horsehead Nebula. And this is well, because it looks like a horse head. I don't know if it looks like something else to other people. It's called the Horsehead Nebula. I think that makes people kind of instantly see a horse head, whether they would have seen it originally or not. And either invisible or infrared. This is an infrared image, which I think is definitely just the most striking image of this nebula. It really does look like a horse head, and it's a bit north of the Orion Nebula. So we're kind of looking to, if you look at the constellation Orion and you look at his belt stars, we're kind of off to the left belt star there. We're kind of in that region of the Orion constellation. And this is a dark nebula, so it's just a lot of dust and gas, and it's being backlit by light behind it. So it just looks like a silhouette of a horse head, but it's just a different, it is a different type of nebula. And I'm actually, what I'm trying to do here is pull up the next thing.
It's a giant space dust bunny or dust horse.
It is. Yeah, there you go. Giant dust horse. Well, what I'm trying to pull up here, let's go back to here, because we get to fly through this one as well. So let me go ahead and stop that share and share this fly through separately. And again, there's no sound. Okay. All right, so hopefully, can you see us flying through the horse head?
Yes.
So
Yep.
in this video, we are, and it's not as, it's not quite like the last one where we're gonna kind of go from all directions, but you're just kind of getting an idea of its 3D-ness.
Mhm.
So, let me run that one more time there. So we kind of go into it. It doesn't have the neat star clusters and thousands of stars that we get to swirl around.
Yeah, yeah.
But it just,
Beautiful.
it's just very striking, and it kind of looks like just a huge mountain of gas with a plateau up there at the top. So yeah, it's just a different gas structure that's in the vicinity of Orion. Let me stop that share. Yes,
We do
question.
have a couple of questions that are coming in.
Okay.
One of them is about our sun. Are there any remnants of the possible nebula that formed our sun? Do we know?
Ooh, that's a really good question. So when our solar system formed, there was some leftover material that went into planets and went into asteroids, went into making comets. And then anything left over from that, any leftover gas and whatnot, was just kind of dispersed by the stellar winds. So there are winds that come off of stars, and it kind of pushes the material out. So anything that did not go into forming planets and moons around planets and asteroids and other objects in our solar system, all of that is dispersed.
I think that's an interesting concept, that there are winds coming off of these things in space. I think everyone thinks of space as like this oddly stagnant but powerfully moving at the same time. So Isla would like to know if stars move. Do stars move?
Do stars move? That's also an excellent question. So actually, stars do move. All the stars that you see up in the sky, it doesn't look like they move because they're very, very far away. But all the stars up there, our sun included, we are all orbiting around the center of the galaxy. Just like planets orbit around stars at the center of the solar system, all the stars in the disk of our galaxy, which kind of looks like a big pinwheel in space, we're all going round and round the center of the galaxy in the same way. So the stars are actually moving, but they're so far away that you don't really see them change their position in the sky for like eons, hundreds, thousands of years. And so over the course of our lifetimes, Orion's going to look the same. But thousands of years from now, you'll see the positions of those stars start to shift, and then he won't look the same. So,
Yeah.
oh yeah.
Wasn't what we use now as the North Star, didn't it used to be kind of different and maybe kind of closer to where Cetus was a long time ago?
Yeah, so as the Earth spins on its axis, it wobbles, and so the North Pole of the Earth doesn't always point in the same direction. So for example, there's a star in Draco the Dragon called Thuban, and that used to be our North Star. And I can't remember how many thousands or tens of thousands of years ago that was, but that was a while back. But yeah, but that's because of the Earth wobbling.
That's the Earth, not the stars moving.
Yeah.
But stars do move, essentially.
Yeah.
How in the world did the gas cloud form in space? How are we getting a gas cloud in space?
Oh, how do you get a gas cloud in space? Well, if you get enough material, so gas, so space isn't totally empty. There's stuff out there. There's mostly hydrogen, as Matthew pointed out. Hydrogen is the most abundant element, and then after that, helium and a little bit of other stuff. If you get enough mass, you get enough hydrogen kind of clumped together, it can pull together other clumps. So anything, and mass has gravity. Anything that has mass has gravity. I have gravity, you have gravity, the moon has gravity. Gravity is everywhere. So if you get enough mass together and it can pull together some more hydrogen atoms and molecules from around it and get it all clumped together, you can get a clump of gas and you've got yourself a cloud of the stuff, just a big bundle of it, or a big giant clump of it. We call it a cloud. So
Very
we're getting some
cool.
really good questions. Matthew.
So one of the things, just to follow up on what Liz said, is that space is full of gas. The galaxy is full of, our Milky Way galaxy is full of gas, but in a lot of places it's really, really thin. There are these places where it's really concentrated and packed together, and those are these nebulae. But there's gas all throughout our galaxy, and it has a really kind of cool word. It's called the interstellar medium. Let me say that again, because it's kind of a big word. Interstellar medium, or sometimes called the ISM. And these places like the Orion Nebula, these are more concentrated areas of the interstellar medium where the gas is just kind of denser and more packed together and such.
Mm-hmm. Yeah, interstellar medium is just stuff between the stars. So yeah. Oh, another question?
We do have another interesting one.
Uh-oh.
How much magnification is used in the telescopes to get these images that we've got?
Oh, like the ones that we've shown?
Yeah.
I don't know what the magnification is on those. I know that they are, for like the Hubble images and whatnot, they are many images taken in different colors of light and also timed exposures. So you're looking at exposures where the shutter of the camera, the detector, is left open for a very long time to collect all of that faint light coming at you to get that sort of an image. But in terms of magnification, I know that's more of a Matthew question. For magnification, for what about the Clark, for that one that you showed at the beginning?
Typically, if we're looking at the Orion Nebula visually, so we have an eyepiece in the telescope and you're looking through the telescope, we'd probably run the Clark about 150 times. So we'd be magnifying about 150 times. But whenever you get a camera involved, it starts to become a little hard to talk about magnification. And astronomers actually aren't thinking so much about magnification when they're taking pictures. They're thinking more about, as Liz said, how much light are you gathering? How long are you opening that shutter of the camera so you gather that light over a period of time? What kind of color filter are you shooting your image through? Because you have to shoot images through multiple filters, like a red filter, blue filter, and green filter, for example, to make the color. So there's just a lot that goes into it beyond magnification. Actually, taking these space pictures is really complicated. Really complicated, takes a lot of time to process them. It's not just like taking a snapshot with your phone.
Yeah, a lot of planning, I would imagine. You have to plan it out very, very detailed.
Yep.
Before we go, I don't want to forget, I think it was Teddy that asked it, and he asked it towards the beginning, but we were already on a different subject area, so I didn't want to interrupt y'all. But Teddy would like to know, what is the moon made of?
Cheese.
I knew you were going to say that.
Oh, no.
Shall I?
Oh.
Well, I'll pass that to Liz.
Well, the moon's, I mean, the shortest answer is it's made of rock. And there's some commonalities between the compositions of Earth and the moon. But it's basically a big chunk of rock. That's our natural satellite, so it orbits around us.
And now Sarah Catherine did answer, and she said that the moon was probably formed when something else hit us, and then it kind of went and kind of popped off a little bit. Can you say a little bit about that before we go?
Yeah, so basically the leading moon theory right now is that an object the size of Mars, so not Mars itself, very important distinction, an object the size, that would be really scary, an object about the size of Mars kind of crashed into the very young Earth. So back in the beginnings of the solar system, it was kind of a construction zone. It's kind of crazy. There's a lot of debris flying around, lots of chunks of rock flying around. And so when the size of Mars hit Earth, ejected a lot of stuff into space. And so that debris kind of came together because of gravity and formed the moon. And then that object was still captured by Earth's gravity, and so it goes around the Earth. So yeah, giant impact back in the day. Good thing we weren't here yet.
That would have been quite a thing. I think that impact came fairly close to destroying the Earth, didn't it?
Yeah, it's a good thing it didn't.
We're a little happy about that. I think Ava and the boys would like to know if the moon contains any interesting minerals.
And that I don't know about. I don't know too much about the mineralogy of or composition of the lunar surface and whatnot.
Gosh, I'm trying to rack my mind too. One of the things that was recently announced is the possibility of really small trace amounts of water in the soil of the moon, in the sunlit part of the moon. And that's kind of weird. It's like, why would we find water where it's sunlit? We've suspected and actually have a pretty good idea that there are small amounts of water in some of the craters on the moon near the poles where you're hidden away from sunlight. But now we think there are tiny little bits of water in the soil on the sunlit side. So that's kind of cool. That was something that was announced back in the fall.
Very cool. Well, is there anything else you guys want to say before we let everybody go? It's almost 8. I see people dropping out.
No, just hope you enjoy this tour of the neighborhood of Orion. Hope it gives you an appreciation of that constellation. It's very popular, pretty easy to find in the winter skies. So the next time it's clear, go out after dark and look for that pattern of stars that suggests a person to so many people, and just think about all the wonderful things that are in that part of the sky that we could only see if our eyes could just pick up that super faint light. And then hopefully next week it'll be clear enough that we can actually see a nebula.
That's right. We're going to look at the Orion Nebula next week, and if it's clear. So we'll keep our fingers crossed for better weather than we had tonight.
Absolutely, absolutely. Thank you guys so much for joining us. Thank you, Matthew and Liz, for being as amazing as you always are. Absolutely appreciate everything you do. We hope everyone has a wonderful night and a fabulous week. Thank you, Teddy. We hope you have a good night as well. Any of our Girl Scouts that are with us, don't forget to join us next Friday or this coming Friday for your special program. And again, just like we said at the beginning, if you are curious about any of our virtual content, just shoot us an email. We are happy to try to help you out and figure out what might work for you and your students. So thanks so much, everyone. Have a great weekend. Bye.
Bye. Bye.
Bye.